Hello everyone and welcome to my channel. In the last video, we solved problem that was pertaining to simply supported beam that was just subjected to a single pointed load. But in today's video, we're going to be solving problem that has more forces acting on the beam. So let's say, for instance, if you are given a problem like this, if you are given a problem like this, alright, if you're given a problem like this to solve and you're asked to find the reactant forces that are acting on this beam, the moment, and also to graph the normal force, the shear force, and the bending moment of this kind of problem, the first thing you have to do is to try to understand the type of support that are acting on the beam. So in this case, we have a pin support. So for a pin support, we're going to have both vertical and a horizontal reaction forces that are acting on this beam. So let's say, for instance, if you try to push the beam on the right or on the left, it's going to resist translation. So that is the reason why you're going to have a horizontal force, right? Horizontal reaction force going this way, right? And in this case, we also have a vertical reaction force. Why? As you try to push down on this beam, we're also going to have a vertical reaction force that will be resisting what you're doing. So that is it. But how are we going to draw it? So in this case, we have a vertical force that is going upward here in this case, right? Because there are forces coming down here. So all these forces that are coming down is pushing down on this beam here, and this one too is resisting that. So that's the reason it is going up, right? So in this case, we have a horizontal force. The horizontal force here, how are we going to draw it? Are we going to draw the horizontal force that is going on the right or on the left? So according to Newton's third law of motion, for every force acted on an object, there is an equal and opposite reaction. So in this case, we have 5 kilonewton force that is going on the right. So in this case, our force here, the reaction force here, will also be going on the left in order to cancel this force out, right? So in this case, our reaction force here, we'll consider it going this way, right? So now the forces are balanced this way. Now, looking at this one, we also have a roller support. And looking at this roller support, are we going to have a horizontal force? No. The reason why we are not going to have a horizontal force due to this roller support is that as you try to push this beam in the horizontal direction, it's not going to resist translation. It's going to go freely because it is relaxing on a roller here, right? So here we have no horizontal force, but for a vertical force, as you try to push down this beam, it's going to create that vertical force too as well. So we have another vertical force. So if we can call this A, we call this B here, right? Then the force here, we call this FAY. We can call this BY here. We call it FAX because it's a force due to A. Call it FAX here, right? So now we have found the various reaction forces that are adding on this beam. The next thing to do is to sum the forces in the both Y and X direction. So summing the forces in both the Y and X direction, we should know that the forces that are going in opposite direction should cancel each other out, right? So let's say, for instance, if we are considering this this horizontal direction here, right, of the forces, we have a force that is going on the right. We also have another force that is going on the left. So this force is going to cancel this out, right? And for this one, for the Y direction, we have forces that are going up, and we also have forces that are coming down. So the forces that are going up will be equal to the forces that are coming down as well. So let's say, for instance, if you have 10, 10 here, 10, 10, that means we should also have 20 here. So in this case, since we have 30 here, the sum of these forces too should also be 30. So always keep that in mind. So here, the formula is going to be the sum of the forces in the X direction is 0 here, right? So summing them out, we have Here we have FAX. FAX is going to be for the 5 kilonewton. 5 kilonewton is equal to that. So that's the value for FAX here. Call this 5 kilonewton. 5 kilonewton. Right. Then for the Y coordinate, some of the forces in the Y direction is equal to 0, 2. So summing them out, we have these two forces that are going up will be equal to these two forces that are also coming down. So we have FAY plus FBY will be equal to 10 plus 20, right? So now summing them out here, we have FAX plus FBY, right? Is equal to 30 here. So now we have two equations. So the next thing we have to do is to find the moment. So for instance, if you get another sheet, the moment is basically the force time perpendicular distance. Call it perpendicular distance here, right? Let's say for instance, if you have a point here, right? We call this point A, and you have a force in this direction, and you are asked to find the moment at point A here. The distance from point A to this force, we call that X, and there is a F, which is a force. So the moment here is going to be this distance down this force, right? So, and the distance is perpendicular to this force, right? So it's going to be the perpendicular distance. When the force is like this, we have this point, and we have the force going in this direction, right? And you are asked to find the moment about this point, right? Here. You should know that it is in the same direction. Therefore, it is not perpendicular to this force. Since it is not perpendicular to this force, then there is no moment, right? So in this case, we have no moment. The moment here is going to be equal to 0. In this case, we have a moment. All right. So for all of the forces that are coming down here, we have this force. All the forces that are coming down here, we'll have a moment about this point. All right. So now, in this case, let's try to solve for the moment. Solving for the moment here, we have the sum of the moment too. The sum of the moment at point A. Let's consider this way. If you like, you can start from this direction. But for us, let us just try to start solving from this direction. I like to always start from A. Take my moment at A. So this one here is going to be, we have the force. The first force that's coming down, which is 10 kilonewton, is going in a clockwise direction. If we consider this direction as positive, which is the anti-clockwise direction, as positive, then the clockwise as negative, then in that case, we're going to have this force that is going in a clockwise direction, negative. So it's going to be negative 10 times 2 meters away from this E, right? We also have this one also going in a clockwise direction, which is going to be negative 20 times, we have 4 here plus 2, which is 6 here, right? So, and we also have another force there. Oh, there's no space. I try to create space here. It's still continuous here, right? So we have this force which is going upward, and this force is creating an anti-clockwise rotation. So the anti-clockwise rotation is going to be positive, right? But from this distance here, from this area to this area, the distance between them is, we have 2, we have 4, we have 4. So it's going to be 10, right? So it's going to be 10. So in this case, we have those 2. We have minus 20 minus 120. All right. Then we also have this one now is going to be 10 here plus 10 FBY. This FBY. Right? So adding these two together, we're going to have minus 140. Minus 140 plus 10 FBY here in this case. So this is going to go across here. It's going to go across. We have 10 FBY is equal to 140. We can divide it by 10 here. So dividing this by 10, we're going to have FBY as 14 kilonewton. Now that we have FBY as 14 kilonewton here, and it is a force that is going up, right? So these two forces must be equal to these two forces that are also coming down here, right? Since these two forces are going up, right? And we have 14 kilonewton here. So 14 kilonewton will be subtracted from this 30 that we have that are coming down. The result is going to give us this force, right? So 14 subtracted from 30 is going to give us 16. So our value for FEY here will be FEY plus, we are using this equation, plus FBY is equal to 30, right? So FEY plus this 14, we got a 30 here. So in this case now we have FEY, which will be equal to 30 minus 14 here. So the result is going to give us 16, right? Since we have 16, so the value for FEY here will be 16 kilonewton, right? Kilonewton. So the next thing for us to do here now is to graph. We need to redraw this. So the next thing we have to do is to draw the graph of our normal force, the shear force, and the bending moment. So one thing you have to take into considerations is whenever you're drawing a graph of your normal force, you're only going to take into considerations of the forces that are going in the x direction. Since we have forces going in the x direction, these forces are going to be on our normal force graph. But for the forces that are going in the y direction, it's going to be the forces that will be on our shear force graph. But as for the bending moment, it's going to be the area under the curve of the shear force graph. So let's get started drawing the graph of our normal force, the shear force, and the bending moment. So we need to redraw this figure on the sheet so that we can be able to draw our graph, right? So redrawing this figure here, we're not going to consider the support here, but rather the forces that are acting on the support, right? So drawing this, redrawing this one, right? We have this beam. What is this? We have this beam here, and there's a force going up. All right, this force is 16 kilonewton, and there is also a force going up here, which is 14 kilonewton. 14 kilonewton. Remember that we saw for this already, is there, and there's a force coming down here, which is just 20 kilonewton force. We also have another force coming down here, which is this one, 10 kilonewton force, right? Then we have a force going on the right here, which is 5 kilonewton. And we have a force also here going on the left, which is also 5 kilonewton. So after drawing your x coordinate, you should also name them. This is our normal force, right? The N diagram. This is our V diagram, which is our shear force. And the next one here under and the next one here would be our bending moment. Here we have our important points, right? We know. So the next thing is to recognize your point of interest. There's going to be some important points on this graph, right? So here, as you can see, we have important point on the graph here, right? Let's try to draw the graph of this. Let me use another color pen. So as we said earlier, that the normal force is only going to take into considerations of the forces in the x direction. So for this one, we have 5 kilonewton force here going on the left. So since this is going out of the material, we'll consider this as positive, and this one going into the material, we'll also consider this as negative, right? Let's say, for instance, if you take this force and place it here, this force will be going into the material. It is a normal force, right? So since it is going into the material, we'll consider it as negative, right? And this is positive. So for positive here, we have positive 5 kilonewton. It go up 5, right? 5 kilonewton. Then from this point to this point, there's no force at the in-between, right? There's no horizontal force at the in-between. So we'll go straight up here. When we reach to this point, we have another 5 kilonewton force that is going into the material. So it is negative. That's going to take us down to negative. So this is going to be a graph of our normal force. That is a graph of our normal force. So the next one is to draw the graph of our shear force. And the shear force is only going to take into consideration of the forces in the y direction. Now we have a force that is going up here, and this force is 16 kilonewton, right? This force here is 16 kilonewton. 16 kilonewton here, right? And 14 kilonewton on this side. So, and this force is going up. Since it is going up 16 kilonewton. So 16 unit up here, right? So this force is here, right? Here, 16 unit. And from this portion, from this area to the force here that is coming down, there's no force that is at in between. So we'll go directly to that. And we have 10 kilonewton force that is coming down, all right? So, and this 10 kilonewton force is going to be negative, subtracting from this 16. So it's going to take us down to 6 unit down here, right? And from this 6 unit down, or from this 10 kilonewton force to this 20 kilonewton force, there's no force at in between. So we have another straight line here. So from this 6, now we also have another 20 kilonewton force that is coming down, right? We have another 20 kilonewton force that is coming down. So this is going to be considered as negative 20, right? Because it is a force that is going in a negative direction. So negative 20 plus 6 is going to be negative 14, right? Negative 14. Bring us down to negative 14 here, right? So, and from this negative 14 to this force that is here, that is going up, right? So this is a 14 kilonewton force that is going up here. So from this force, this 20 kilonewton force to this 14 kilonewton force, there's no force also acting in between. So it's going to be like this. And 14 here, which is positive, plus this negative 14 is going to take us to 0. So this will be the graph of our shear force. This will be the graph of our shear force. And now, as for our bending moment, I want you to take few things into consideration. Always note that when the graph of the shear force is positive, the graph of that section under the bending moment is going to be negative. If this is positive here, the graph is going to be negative here. If it is negative here, the graph is going to be positive here. All right? So always consider that. Let's say, for instance, if you have this like this, you have this this ruler, and there's a force that is acting on this beam from the top here, and your hand is like this, right? So if there's a force acting on this beam, it will tend to push this down, while your hand under this ruler is also trying to resist that, right? So it's going to cause a sagging moment, right? So the dangerous cross section here is going to be what? The global minimum. Now there will be a minimum here, right? So that's the reason your graph is going to be going down this way. So in this case, we have forces that are pushing down on this beam, trying to break the beam, and we have a support that is trying to resist that, right? So considering this one, we have 16 here, right? So the area under the curve of this shear force is going to be the bending moment. For a rectangle, area is going to be the base times the height, right? And the base in this case, according to the graph here, is 2 meters, right? So considering this as 2 meters, it's the same 2 meters here. Then here is 4 meters, and here is also 4 meters, right? So the base here is 4, and we have 16 here. So that is going to be 36 multiplying that out. So 16 times 2 is going to give us 32. 32, right? Since it is positive, it's going to be negative here. So it's going to be 3, 2 here, right? And also consider this relationship. We have few relationships that you need to take into consideration whenever you want to draw your bending moment graph. If the shear force graph is a straight line, the bending moment is going to be an inclined line. If it is an inclined line, it's going to be a parabolic line. If it is a parabolic line, then the next graph is going to be a cubic line, right? Just consider in this case, let's say for instance, if you have 5 here, right? The integral of the shear force graph is going to be our bending moment. For instance, if you have a straight line, 5 in this case is going to be a straight line, right? On a graph, it's going to be a straight line going like this. So if you integrate this, 5 is going to give us 5x, right? Integrating 5x is going to give us what? It's going to give us 5x raised to the power 2 divided by 2 here, right? Continue that way. So if you try to integrate this 1, 2, is going to give us something like 5s or 2. This will be 3 divided by 3 here too, right? So multiplying this by this one, you're going to have 15s cube divided by 2 here, right? So I don't just want to get you bored with this integration. So let's try to just continue our graph in this case. So since this is a straight line here, and we already know that the relationship here for the shear force graph, when it is a straight line, the next one under is going to be an inclined line. So this is going to create an inclined line here in negative direction, right? So the next graph is this section, right? And the height of that is 6. So 6 will be multiplied by 4, since 4 is the base of that. So that is going to give us 24, and it is positive verse. Saying it is positive here is going to be negative, right? So negative 24. And notice that this is a negative value, right? So adding the 2 negative value here is going to give us negative 56, all right? So it's going to take us down again to 56 unit, right? This is 56. Coming down here to 56 unit. Let's go ahead and continue. This one continue down here. Continue 56 unit here. We have 56, 56, right? And now we have this section, which is 14 unit as the height. The base here is also 4 unit, right? So 14 times 4 is going to give us 56 as well, right? Since it is negative here, it's going to be positive. So 56, positive 56 minus 56 is going to be what? It's going to give us 0. And notice that it is also a straight line, so it's going to be an inclined line. So taking us back to 0. That's going to be the graph of this. So right, in this case, this is a graph of this bend moment.